Welcome everyone to this presentation. My name is Dennis Torres. I'll be talking about Azure SQL Network Secrets. So this is me. My name is Dennis Torres. I'm a data platform MVP working for the Tower Software. I have some Microsoft certifications and I live in Malta. I'm the leader of the Malta Data Platform User Group. And you can see on the screen my contacts. Feel free to get in touch. It will be a pleasure to stay in touch. And in the agenda today, we'll talk about allow Azure services, a configuration in Azure SQL, the two Azure SQL firewalls, Azure AD Authentication, connection to secondary replicas, redirect versus proxy versus the full configuration, self link and private link. So never activate the configuration allow Azure service. That's our first subject in relation to network secrets about Azure SQL. Never activate this configuration. What configuration I'm talking about? This one. When you go to networking in Azure SQL, you see this option. Allow Azure services and resources to access this server. Yes or no? Never activate this in a production environment, in a serious environment. On many tutorials, you may see a recommendation. Oh, you need to activate this option for this tutorial. Why? Because sometimes you need to make a huge workaround in relation to this configuration. And the tutorial wants to keep everything simple, the demonstration simple, and asks you to activate this option. Never do that. You can do for a tutorial, but never do that for production. Why you should never do that for production? What's the secret of this configuration? The secret behind this configuration that most people think, oh, I have some Azure services, I have here one app service, I have another virtual machine, I have some services inside Azure. If I activate this configuration, my resources inside Azure will be able to access the Azure SQL, correct? Wrong. When this configuration mentions Azure services, it's not talking only about your services. It's talking about any service, everyone's services. Any service inside Azure will be able to access your Azure SQL. Oh, they'll be able to query your data. No, no. Security in networking is like an onion. We have many layers of security. Creating layered security is a pattern in security in this case. So the firewall in Azure SQL is one layer of security. After that, you still need to authenticate to Azure SQL. But why would you just deactivate this layer for every session inside Azure and take out one layer of your security for every session inside Azure? You shouldn't. You shouldn't. So you should never activate this option. Later on this session, we'll talk about alternate options to this one. Okay, so never activate allows Azure services. Why? Because it's not only for your services. Any Azure service will bypass your firewall. So what's the alternative? What are the options? Use virtual networks. Use virtual networks, link your Azure SQL to a virtual network, and make the access using virtual networks. So use virtual networks and configure the access of virtual networks. That's the option. A tale of two firewalls. At this point, many people may be asking, two firewalls? Two firewalls in Azure SQL? Yes, That's the truth. There are 2 files in Azure SQL, and most people don't know that. Most people don't know that Azure SQL has 2 files, but it has 2 files. And the sequence about how Azure SQL processes these file rules will even be another surprise. Let's take a look on this. See, the file that everyone works with is the server level file. Why everyone keeps working with the server level file? Why everyone keeps working with this file? Because this file has a user interface. This file is located in the portal, in Azure portal. So everyone can go to Azure portal and can see the file there. And everyone sees the file there and immediately thinks, let's open this file for some IPs or for some services and so on. So everyone keeps working with the server level file rules. But Azure SQL has another file, is the database level file. And the database file rules are checked before the server level file rules. Before checking the server level file, if you have access to something, Azure SQL will check the database level file. We'll check the database level file to see if you have access to one specific database. And if you have access to that database, then you connect to that database and that database only. You'll be able to connect to that database and that database only, not the other database. So you'll be able to connect to one database, not all of them. Basic security rule. Use the minimum permissions possible. So why will you keep creating server level file rules if all that your application needs are specific database level file rules? Why will you be opening file connections to your entire server if your application only needs the connection open to one single database or two single databases or whatever is exactly the need of your application. So basic security rule, use the minimum permission possible. If the application only needs access to a database, don't open a server level file rule. Use the database level file. Always remind that there are 2 files in Azure SQL, not one, 2 files. So use the database level file to access the server, not the server level file. So here we see another drawing about that. So the database level file is checked first. There are other configuration, other network configuration like the deny public access. If the deny public access is activated, the file will not even be checked. Not even be checked. But if if this option is not enabled, so the Azure SQL is enabled for public access, then first, it will check VNet file rules. VNet file rules will come first. Then, database level file rules. And finally, server level file rules. Server level file rules is the last one to be checked. These rules are located in different system tables, but the server level file rule is visible. File rules are visible in the portal. In the Azure portal. That's why everyone goes to it. When, in fact, we could be working with database level file rules. So let's see an example about this. I have here one SQL database. I have one virtual machine, and I have my local machine. First, I'll connect to that database from my local machine. From my local machine, I'll connect to this database. The file rules are not on the database, they are on the server. So here on the server, we can see in networking, the public access is enabled, but there are no file rules included yet. No file rules are included yet. So first, I'll connect from my machine to the server. Let me put my password. So SQL Server Management Studio is a tool. It is a tool to manage the Azure SQL. So it identifies immediately the answer from Azure SQL, the question, oh, we need file access. There is no file rule for that. The file is blocking this connection. So the Management Studio gives us the possibility to immediately open a file rule. This message is extremely tricky because every developer that sees this message usually goes and just open the firewall and that's it. Don't do that. You need to analyze this window multiple times, many times to really understand if you need to open this firewall or not. In my example, this first example, I will open the firewall. I use my Azure account. I need to log in as an Azure administrator, at least as someone with access to that Azure SQL Server. Oh, sorry. It was showing another window and approve of the authentication, request approve of the authentication. That's why it was taking some moments to complete. And authentication approved, and now I'm able to create a firewall. But when I'm creating this firewall, what most people forget is that I'm creating a server level firewall. How do I know that I'm creating a server level firewall? Simple. I can see all the database in the server. This is one reason to know that we are creating a server level firewall. This server level firewall allowed me to see all the database in the server. That's not good. That's not good at all. Creating this server level firewall is not good at all. Let's take a look on our firewalls. So we can refresh this and refreshing this. We see here that a rule was included to my IP. This was done by SSMS. SSMS on my local machine included this firewall. Now let's imagine that I'll do the same from my virtual machine. This virtual machine is inside Azure, inside the same region than this Azure SQL. It's inside the same region than the Azure SQL. So I'll try to do the same connection. Okay, and again, one more time, I'm seeing the window to open a firewall. So now I can be more careful and not use this window to create a firewall. In this case, I'll check the IP and I'll use the IP to open a new firewall, a database firewall, an open firewall in the database level. So let me go to my local machine. On my local machine, I can connect to the database. Let me connect to the SQL Start DB. open a query to the SQL Start DB. And here on this query to the SQL Start DB, I use the stop procedure sp set database file rule, and I specify one file rule. I need to know exactly the IP 51 13 118 51 13 118 and 126. 126. This is the IP, so I'll be creating one file rule on the database level for this IP, but only for the SQL Start database. So I will execute this stop procedure. Executing this stop procedure, the file rule is created. I can check the database file rules. For example, let's list the file rules. And here we can see the file rule is created inside this database. This file rule is created inside this database. Oh, so what I do here on this window, I cancel. And another reason for people to get confused on these windows, this connection windows, is because if I try to connect again, I'll see the same window again. But why? I already opened the firewall connection for this machine. Yes, I opened the firewall connection for this machine for one database, the SQL Start DB. And when connecting, I'm not telling to what database I'm connecting. So it will only check the file, the database file, if I tell to what database I'm connecting. I need to tell that. So I need to include here the database name, SQL Start DB. Also include the database name and connect. I'm able to connect to the SQL Start DB because I already have a database level file rule on the SQL Start DB. Okay, but I also ask it to connect to one single database. This is a technique also called container database. That's the reason why I don't see the other one. Yes, true. That's the reason why I don't see the other one. But first, we already saw that if I try to connect without telling the database name, I will be asked to open file root. But I can try with the other database name as well, just to be sure. Just to be sure about what we are doing. Empty DB. I can try with the other database name as well, and we'll see to the other database, I will see the same screen. Open a file rule because I don't have permission to the other database. I have permission to the SQL Start DB. So I open it, the best permission possible, which is the smallest permission possible on the database level. I open the permission on the database level. Okay. Then I will not keep this file room. I'll drop this file room, and there is another procedure used to delete the database file room. So I can just delete it. But I will not execute yet. I have not executed yet. I can go to the server level, make a refresh here on the server. So I can make a refresh here on the server and networking window. And what I'm trying to show is that that IP doesn't appear here. It's a database file rule, and the database file rules are only configured inside the database. We don't see them in the portal. The file that we see in the portal is a server level file that we should not use so often as most people are used to. So we should avoid to use server level file more than we are used to. Okay. Then let's delete the database file. So I dropped the database file, and let's move ahead on our presentation. Now let's talk about Azure AD Authentication. Why Azure AD Authentication? My connection at the moment is being made with a SQL standard authentication, a SQL Server login. So instead of using SQL Server login, I can enable Azure AD Authentication for my users. For my users, I can enable Azure Active Directory Authentication in SQL Server. This makes the environment safer than only using SQL Standard Login. SQL Standard Login, they are safe, but Azure Active Directory logins are safer, way safer. There are many techniques to keep them safe. What do you need? Do we need to activate the Active Directory authentication? We need to define an Active Directory administrator to our Azure SQL Server. Once we define an administrator to our Azure SQL Server, our Azure SQL will accept Active Directory authentication. So let's do that. So we define an identity as server admin. Use a group instead of a user. What do I mean? I mean that it's not a good practice to use users directly in this kind of position. Put a user as admin of an Azure SQL Server. Then the user leaves the company and that user account doesn't exist anymore, and you need to end up fixing everything. Everywhere where you put that user. So it's not a good administration practice to use a user account for that. So you create a group account and you put the group as an admin to your Azure SQL. Optionally, you can use the option to accept only Azure AD authentication. What this means? This means that Azure SQL logins will not work anymore with your Azure SQL. Only Azure AD authentication will be accepted. Enforce these configurations using policies. Azure policies are used for governance. I wrote many blog posts that you can find on Simple Talk website about Azure policies, and some of these blog posts were exactly about how to enforce these policies, these configurations using Azure policies. You can enforce that all your Azure SQL should be using only Azure Active Directory Authentication. For example, you can enforce this kind of policy in your environment, or part of your environment is a decision that you can make. You can make this kind of decision. Okay, let's see an example about this. So I'm on the server, and here on the server, Azure Active Directory. Let's wait to the load message, okay. Then I need to set an admin to this Azure SQL Server. Set admin. On my Azure Active Directory, I have a group that I created exactly for situations like this, which is the SQL admins group. SQL admin. So I put this group as administrator of my Active Directory. That's it, SQL admins. I can optionally enable this option. If I enable this option, my Azure SQL Server will not accept standard logins anymore. Let's enable it now, then I'll disable it later. I'll use both. Okay, for now it's enabled. Then let me close these windows. Then I'll connect. To make a connection using Azure, I need to use this option, Active Directory Universal with MFA. Active Directory Universal with MFA. Okay. Then I specify my Azure login, user principal name, and my connection will be made with Azure. Once Azure authenticates me, if I have access to this Azure SQL, I will receive the access to this Azure SQL. Great. What happens now if I try to use a SQL Server authentication? Let's try. Login failed. Why? Azure Active Directory only authentication is enabled, so this server is only accepting Azure Active Directory users. It will not accept authentication from Azure SQL logins. This Azure SQL will not accept standard SQL login. Oh, but what about your applications like Azure Functions, App Services, and so on? All your applications can receive a user assigned identity, also called a managed identity. You can give your applications a user identity and give permissions to your application to access your database. And they don't even need to be included on the SQL admin. You create them as external logins inside your database. And your applications will authenticate to Azure SQL using Azure AD Active Directory. Azure AD Active Directory to connect to Azure SQL. So, not a problem at all. For now, just for the demonstration purpose, I will disable this, but the safer option is to keep this option enabled and be using only Azure AD Authentication. There are a few exceptions. If you may be using some kind of application to connect to this Azure SQL that doesn't support the Azure AD authentication, the Azure AD and MFA authentication. In this case, you would need to keep the standard SQL login. But if you can enable this option, this is the safer option. Okay. Secondary replicas and connection. What I'm talking about? Well, our Azure SQL is a platform as a service, is a PaaS service. This means that Microsoft manage most of the work for us. Most of the work is managed for us. So many people doesn't know exactly how Microsoft manage high availability behind the scenes. The method Microsoft used to manage high availability behind the scenes depends on the level of your Azure SQL, the service level of your Azure SQL. The general purpose service level is managed in one way. The business critical service level is managed in a different way. What's the difference of these service levels here? The general purpose service level manages the high availability using storage replicas. So the machines use storage replicas to replicate their disks. This is based on this Azure storage accounts, Azure storage accounts high availability. And if a failure happens with your machine, these replicas will take place and be put up and running again. But this is a general purpose scenario. In a business critical scenario, the machines use secondary replicas in an always on environment. And the secondary replicas, they are on and available. So if your machine suffers any failure, if the machine which holds your Azure SQL suffers any failure, it's immediately redirected to the secondary replicas. An immediate redirection to the secondary replicas happens. This is basic details about the always on availability group. Basic details about the availability group. Okay, the point is that these secondary replicas are readable. You can make connection to them. You can make connections to the secondary replicas of your Azure SQL if your Azure SQL is on the business critical level. Then, if you design your application in such a way to define what your application plans to do on each connection, if your application plans to read and write, or if your application plans to only read on each connection, so the Azure SQL will automatically redirect your application to the connection with the secondary replica. It's even difficult to notice that because Azure SQL manages everything for us. So it's not something easy to notice. But yeah, you have, let's say you have two servers. You have two servers. If you plan your applications correctly, if you plan the connection strings correctly, you can make a good use of these two servers. This gateways in connection ring here is a method of connection to Azure SQL in both layers, general purpose or business critical, or I would say more in all layers. The connection always passes through the gateway to reach the Azure SQL. Always goes through the gateway to reach the Azure SQL server. We'll talk more about these gateways like called control rings. We'll talk more about them in a minute. Let's see an example of connecting to secondary replica. I have here my SQL Server. The first thing that I need to double check is, sorry, I need to check this on the SQL DB. Compute and storage. So I can see here that this SQL DB is on the business critical level. This SQL DB is on the business critical level. And you see here, read scale out is enabled. This means that the secondary replicas will be enabled for reading. How do we make a connection to the secondary replicas? Simple. First, I need to specify the database. SQL start DB. I need to be connected specifically to this database because the level of the service is defined on the database level. Then I need to add some additional query parameters. I need to add to the query string the intention of my connection. The intention of my connection is to only read data. So I'm adding the intention of my connection. This enforces the redirection to the secondary replica. So I can connect. It's very difficult to notice that I'm on a secondary replica. I'm not on the primary replica of my database. I'm on a secondary replica. The only property that we have that we can check to prove that we are on a secondary replica is a database property called updatability. This property will come as read-only. The secondary replica is read-only, so I'm connected to the secondary replica. So the only thing I had to do was to add the application intent in my connection string. Adding the application intent in my connection string I get connected to the secondary replica. So all your workload, which is focused, very focused on the primary replica, can be broken down between the primary and the secondary replica if you add the application intent to your connection strings. Add the application intent to your connection strings and you'll be breaking down your connections between the primary and the secondary replica. That simple like that. So let's move ahead and now talk about self-link. Well, let's talk about self-link. We need to go to the virtual machine and talk more about how dangerous this window is. This window is way more dangerous than you think, and that's how you notice that. Many people doesn't notice these small details. What are these small details here? My virtual machine is inside Azure. My Azure SQL is inside Azure. So one basic security behavior that I would expect, since my virtual machine is inside Azure and my Azure SQL is inside Azure, is that all the communication between the virtual machine and the Azure SQL goes inside Microsoft network, inside Azure. I'm not expecting that any communication between this virtual machine and the Azure SQL will cross the internet. The virtual machine will pass through internet to reach the Azure SQL. I'm not expecting that. No one is expecting that. But that's exactly what is happening. The communication between this virtual machine and the Azure SQL is crossing the internet. This makes the communication not so safe as it could be. And how do I know that this communication is crossing the internet? Well, of course, you can track the communication, but the method that we know that is by checking the IP address. It is asking to be opened in the firewall. It is asking us to open the public IP address of the virtual machine. This virtual machine is using a public IP address to connect to the Azure SQL because it's going through internet. It's going through internet. Then the virtual machine is using a public IP address to connect to the Azure SQL. So this is way more than opening a firewall. If this window appears for you, you need to think about, should you need a firewall? Should you be requested a firewall on this situation? If the communication is going inside Azure, you should not be requested a firewall in this situation. How do we solve this problem? How do we solve this problem? Okay, we can manage this problem by defining connections with virtual networks. My virtual machine, you can see here the resource script that I have. The virtual machine is here, the virtual machine, and my virtual machine is inside this virtual network called SQL Start 22 virtual network. My virtual machine is inside this virtual network. So I will open connections between my Azure SQL Server and that virtual network. So add a virtual network rule. Okay, to what virtual network? It already located my virtual network because this virtual network is on the same region than this Azure SQL. They are on the same region. If they were in different regions, there would be other methods to do that. but they are in the same region. And so I connect to the virtual network in the same region, and I create my virtual network rule. I'm specifying the subnet. This virtual network has only one subnet. Okay. And this UI is giving me an advice. Is giving me an advice that a SaaS endpoint is missing in this virtual network. There is no SaaS endpoint for Microsoft SQL enabled in this virtual network. So it needs to enable the SaaS endpoint. But just for us to have a better understanding about what is this, I will ask you to ignore the missing Microsoft SQL SaaS endpoint. Let's ignore this configuration. Let's ignore that the SaaS endpoint is missing. And let me click OK here. While it's updating the virtual network rule on the SQL Server, we can take a look on the virtual network. And on the virtual network, we have here a set of items called SaaS endpoints. Where are you? Here. So we have a set of items called SaaS endpoints here. And on my virtual network, I have no SaaS endpoint at the moment. Like that message said to me, you don't have a SaaS endpoint for Azure SQL at the moment. Yes, I don't have a SaaS endpoint for Azure SQL at the moment. That's it, I don't have. And the rule for the virtual network is working. I mean, it's created. In fact, it doesn't mean it's working. The rule is created, it's here. It's here, we can double check the rule is completely present here to the virtual network, but it doesn't mean this rule is working. Because now I will try to connect again, and it will continue crossing the internet. It will continue to cross the internet. Why? Because for me to allow a virtual network to connect to a SaaS, and this is valid for almost all Azure services. Azure SQL is only an example here. For me to allow a virtual network to connect to one specific service without going to the public endpoint of the service, it means without crossing the internet, making the connection totally internal to Azure, to the Microsoft network, I need to create what is called a SaaS link, or sometimes it receives also the name of SaaS endpoint. On the UI, you see as the name of a SaaS endpoint. This really needs to be created. This guy needs to be created here, pointing to Azure SQL, and this will establish a private routing between Azure SQL and this virtual network. A private routing will be established between both. So let me delete this virtual network rule. I'll delete this network rule. It's gone. I'll create it again. And now I will leave the default option, because the default option automatically identifies for me you have a missing SaaS endpoint. Let me create it for you. I just need to click enable, and at this moment this SaaS endpoint is being created. The first thing this UI did was to create the SaaS endpoint on the virtual network. If I come to the virtual network, make a refresh here, I see the SaaS endpoint to Microsoft SQL. The SaaS endpoint is created. Now, with the SaaS endpoint created, having the SaaS endpoint created, I can click OK. it's almost if I'm clicking the same button twice. But before, the button was called Enable. And after enabling the CFC endpoint, the button changed to OK. And I click the OK button, and it will create the virtual network rule inside my Azure SQL Server. Okay, so I'm seeing this virtual network rule inside my Azure SQL Server. Here it is. Now, the connection that I will make from this machine to my Azure SQL Server will be totally made through Microsoft Network, will never cross the internet. So now I'll be sure the connection between the virtual machine and that Azure SQL Server will be private. So I can connect, and here it is. See, I received no specific request. I received no specific request about opening file rules. In this case, I have no need to open a specific additional file rules. The file rules is the check about the virtual network. The virtual network is, in some ways, a file rule. And since my machine is inside my virtual network, the virtual network that I approved on Azure SQL, so I connected. So see how that window is very tricky. Besides opening file rules in our Azure SQL Server, that window was also hiding the fact that my virtual machine would send package across the internet to the Azure SQL. And now it will not anymore. It will not do this anymore. So let's back to this about the CFC link. The CFC link is how we call this routing rule to ensure an internal Azure route to SQL. We create this CFC endpoint, or CFC link, from a virtual network to Azure SQL to ensure this internal Azure routing to Azure SQL. No internet traffic. Enables the use of virtual network rules on the firewall. When I try to include the virtual network rule on the firewall without having the CFC endpoint, CFC link, it was ignored. It was ignored, and it still requested me to open firewall because the connection was going through internet. It was still requesting me to open a firewall. The public endpoint is still needed. Yes, the CFC link only works in scenarios where I still have a public endpoint. And the CFC link is built for this kind of scenario. For some reason, I don't know why, you need your Azure SQL to be public, to have a public endpoint. Like here, that I was connected to my Azure SQL. I could connect to the Azure SQL. Now, why? Because it has a public endpoint. I can connect from my laptop to the Azure SQL because it has a public endpoint. If for some reason you need your Azure SQL to have a public endpoint, your solutions will use the CFC link to ensure your applications inside your Azure environment will make private connections to your Azure SQL. The connections to your Azure SQL will be private. Okay, we just saw the demonstration about the CFC link. We just saw it working. Now let's talk about another special network configuration with direct versus proxy versus the full configuration. What is this? What is this exactly? This is a configuration called connection policy that we can define in your Azure SQL. We can choose between the default configuration, the proxy configuration, or the redirected configuration. We can choose which connection policy we will use. What are these configurations? Remind that I told you that we would talk about the gateways again. That's it. That's when we'll talk about the gateways again. When a client to Azure SQL, to the underlying Azure SQL, it goes through the gateway. How the gateway will make the connection to the Azure SQL? There are two possible connect methods. One is called proxy, the other is called redirect. The proxy method is when the gateway stays in the middle of a connection. The gateway becomes a main in the middle of this connection to Azure SQL. So the gateway is a main in the middle in a proxy connection. So every query, every exchange of packets between Azure SQL and the client machine pass through the gateway. The gateway is a main in the middle. The redirect method is when the client application makes the call to connect to the Azure SQL, and the gateway makes a redirection to the Azure SQL. So the client application will connect directly to Azure SQL with no main in the middle, no gateway in the middle. What's the difference? Security versus performance. That's the difference. The gateway as a main in the middle to the connection ensures that the client machine never has a direct contact with the underlying servers holding the Azure SQL. But when we use the redirect as the method, the client machine has a direct contact with the underlying servers holding the Azure SQL. So the proxy will be safer. The proxy connection will be safer, but it will not perform so well as the redirect connection. The redirect connection will provide a better performance. So we'll have a better performance with the redirect. When to use each one? Well, the default option is a great option for the connectivity model. The default option is a great option for the connectivity models. What's the default option? The default option tells the gateway to use the proxy connection if the connection is coming from outside the Microsoft network. But if the connection is coming from inside Microsoft network, then the gateway can use the redirect connection. Another benefit from making a correct configuration, network configuration on our environment, the gateway will be able to identify the connections coming from inside Microsoft network, and will be able to enable redirect connection for us. So the default configuration is already good enough. So the proxies made from outside Azure, connections from outside Azure use proxy, and connections from inside Azure use the redirect. Why do we need to know that? If the default configuration is already good enough, why do we need to know that? First, to ensure that our connections are correctly configured, to ensure that our connections from internal Azure services to Azure SQL are really identified as internal Azure connectors. So we can identify them as correct connections. Second, because the redirect protocol, the redirect connection to work has many networking requirements, and in some moments we may need to dig into these networking requirements to ensure that the redirect connection will work correctly. If any of the redirect connection requirements is not available, any port, any specific open requirement is not available, the connection will fall back to be a proxy connection. Okay, and what's exactly the difference? Let's try this here on my specific environment. On my specific environment here, let me close SSMS. With SSMS closed, let me go to my database server, connectivity. So here you see the connection policy, the full proxy or redirect. Let's first set it to proxy and save. This will force all connections, either from inside Azure or outside Azure, to use the proxy mode. So let's make a connection using the proxy mode and analyze the results. I open a notepad to take notes of the result. Let's wait a minute. SSMS is opening on this VM. SSMS is thinking about something before opening. Okay, it's open. So all the connections will be made using proxy mode. So I can connect here and I will be using proxy mode. I already opened the Azure SQL Server for my virtual network. So specific firewall rules will not affect this connection. I can go and connect to my server. I can see both databases now on my server level. Then I'll make a new query to one of these databases. Okay. This database is the AdventWorks Little sample database. So I'll make a query, select the star from sales little.customer, and to give a bigger impact, I will ask to repeat 50 times this query. I will ask to repeat this query 50 times. And I will ask here to enable, where it is, include client statistics on the result. And let's execute. It's executed. All the results executed 50 times. Client statistics. I ask it to include client statistics. Wait time on server replies, 156. It's not too much, but it is something. Okay, 156. Let me disconnect, close everything. I closed everything. Now I'll change the connection policy to redirect, save. Okay, so I changed the connection policy to redirect, save it. Now my Azure SQL is using a different connection policy. I open SSMS again in hope that everything will work fine, because there are many rules in relation to these connection policies. I hope I'm not forgetting any one of them. Okay. New connection. I'll copy the query here. And I will enable client statistics. Execute. Client statistics is slightly smaller. Is slightly smaller. Not enough to prove my point, but is slightly smaller. 125 on wait time. So the client had to wait less for the server. This is a business critical server with a good level of performance and networking and so on. This difference can be bigger. The difference between the proxy connection and the redirect connection can be way bigger depending on the workload that is executing, the SQL server, the Azure SQL that I'm connecting to, and so on. So we are seeing a slightly smaller difference, but this difference can go way bigger. So the point is, it's a good idea to ensure a good networking configuration and try to reach the redirect connection policy from inside the Azure environment, from your application working from inside the Azure environment. So your connection will achieve a better performance. You will receive a better performance by using the redirect connection policy. Okay, let's go back to our PowerPoint. Now let's talk about private link. Why? What is private link? Why are we going to talk about private link? Simple. The question is not why are we going to talk about private link. The question is why I'm making my Azure SQL public. If this were a SQL server in your on-premise environment, would you make your SQL server in your on-premise environment public to the internet? Would you do that? If you would not do that, why are you doing in the cloud? Why are you making your Azure SQL public? There is no reason for that. So I can just totally disable the public access. Why this Azure SQL needs to be public? This Azure SQL doesn't need to be public. So I completely disable the public access from this Azure SQL. So I will enable private access. How I will enable private access? Creating a private endpoint between this Azure SQL and a virtual network. Private SQL endpoint. Norway East is the region I'm using. Okay. Target resource, SQL Server. My target is SQL Server. Virtual network, my virtual network, where my private endpoint will be connected to. Okay. Can dynamically allocate the IP address. Okay. And let's make some tests here. In fact, now that I disabled the public access, before enabling the private endpoint, let's make some additional tests. First, we disable the public access. Since we disable the public access, I cannot connect to this SQL anymore, unless I establish a private access, which I haven't established yet. I haven't established the private access yet. So let me open the SMS again, try to connect. and it's advising that I can't connect. Connection was denied since denied public network access is set to yes. So you don't have access to this secret. We don't have access to this secret. No access at all. And to show what will happen when I create a private endpoint, we can use DNS lookup. DNS lookup is a command prompt tool to check the DNS resolution. I check the DNS resolution to our Azure SQL Server, and this is the result that comes back, which is basically the public endpoint for the Azure SQL Server, but the connection to this public endpoint is denied. We can't connect to this public endpoint anymore. Now, I will create a private endpoint. I will enable the private endpoint. DNS, a DNS zone will be created. Tags, review and create, and create. So the private endpoint is being created. Some additional networking objects will be created to gather this private endpoint. So let's wait some moments until the private endpoint is created. I think I'm delayed just a few minutes on this session, but the private endpoint is our last subject. Let's just wait for it to complete, and you'll be closing the session on it. We'll check the results and be closing the session. I can't connect to this SQL server from my local machine as well. I can't connect from my local machine, not even after the private endpoint is created. I can't use the private endpoint to connect from my local machine to this Azure SQL. So if I really want to connect from my local machine to the Azure SQL, how I would establish this connection? In this case, to connect from my virtual machine to the Azure SQL, I would need to establish a VPN gateway between my local machine and virtual network. So I would need a VPN to make the connection. The deployment is still finishing and it's done. So let's take a look on the resource group and we will discover everything that has been deployed inside the resource group. So what has been deployed inside the resource group? So the private endpoint was deployed inside the resource group. That's it. But the private endpoint created a private DNS zone The work of the private endpoint is based on DNS redirections. The private endpoint created a private name for the Azure SQL inside this virtual network using this private DNS zone. And to ensure the, let's say, collocation of this Azure SQL inside our virtual network, a network interface for the private endpoint was created as well. So the Azure SQL got a network interface on the private endpoint inside our virtual network. If I take a look on the NS lookup results in my virtual machine, see how the result is completely different? I tried the same server, but now the name of the server was served to the private link, to the private endpoint, and to a private address, not to a public address, but through a private address. Now, if I try to connect from my virtual machine to the Azure SQL, the connection works. And my Azure SQL is completely private, not accepting any internet connection. My Azure SQL is not accepting any internet connection, only connections from inside the Azure environment or connections through a VPN that we would need to configure to inside our virtual network in the Azure environment. That's it. So that's the idea of the private link and private endpoint. Insert a SQL endpoint inside the virtual network. Firewall rules are not needed anymore. The public endpoint can be dropped. I mean, the public endpoint of the Azure SQL. Service link is not used anymore as well. It's based on DNS rules. We saw these on DNS lookup. It needs to be in the same region. The Azure SQL and the virtual network needs to be in the same region. Then there are networking techniques to make these work across different regions. Region peering and DNS zones can expand to new region, what I was talking about. There are networking techniques to expand this access to different regions. Then we saw the example of the private link, and here are my contacts one more time. It will be a pleasure to stay in touch. Feel free to connect on my social medias. Stay in touch, send to me any questions you may have, and thank you very much for attending this session.